Hello, good afternoon. We're going to go ahead and get started. I know some of you are still getting your food here, so please feel free to get your food and be seated. My name is Yvette Subramanian. I'm here with CITRIS, and today we are welcoming Robert Munro from Stanford University, who's going to speak to us about leveraging machine learning and crowdsourcing to process text messages in the world's less resourced language. Just a reminder that we have composting in the back for everything except for the plastic bottles, and I think that's it today. So please compost and do your best for greening up the world. And we have our Eye for Energy speaker series is also going on at lunchtime on Fridays. So we have a great speaker this week from University of California at Davis, and so she's going to talk to us about energy efficiency there. And basically, I'd like to introduce Robert Munro. He's a computational linguist working in communication technologies, especially in less resourced languages, which is a broad area of technological and social development, from crowdsourcing and machine languages for extracting rich information from natural language to the installation of supporting infrastructures. So it should be a very exciting talk. Please join me in welcoming Mr. Munro.
Okay, thank you, everybody. Okay, so something that's changed a lot in the last few years is the number of languages that you could potentially have a conversation in any given day. And it's interesting to think about this in terms of not just the technology that supports it, but what does it mean for our communication and information strategies and processes. So to look at how this has changed, so up until about 100 years ago, you probably could hear maybe 5 languages in a day. So most people for most of history have spoken about 2 to 3 languages. And then, they'd have the ability to counter maybe another 2 to 3 in their daily lives, be it the language of, a neighboring village, a traveling merchant, etc. So the average is about 5, like across the whole world. Obviously, it varies locally. This actually dipped a little bit with the Industrial Revolution. So we started seeing these very large monolingual societies, such as the ones we have here in the US and some parts of Europe. This rose dramatically with the landline telephone. All of a sudden, people across the world could communicate with each other, but it's still a very small part of the world which had these landline telephones. So it averaged out to around about 1,500 languages per person on Earth. Right now, it's 5,000 languages, and that's thanks to the cell phone. So if you typed in the right numbers on your cell phone right now and made that call, you could find speakers of 5,000 distinct languages at the other end. And this is actually going to drop off because we are facing a very large loss of the world's linguistic diversity right now. So either by the end of this century, certainly within a few centuries' time, linguists generally agree that we're going to lose about 90% of the world's languages. So we exist in this very thin sliver of time where we can have communications across so many languages with such diversity, but because this is so new, we'll never be under-resourced as we are right now. So for about half these languages, our entire scientific knowledge will consist of, perhaps a dissertation written by a hippie linguist in the 1960s and 70s and a few accompanying articles. And yet, these people now have cell phones, they send text messages, and so when they are faced with a crisis, or when they need to conduct banking, when they need to communicate with their relatives, they'll be using their phone and each of these 5,000 languages. And in a crisis situation, we are going to increasingly see situations like this. So this is Haiti in the wake of the January 12 earthquake. You'll see that there is substantial damage to the houses here. Of course, you've all seen this on the news. But the cell tower is largely undamaged. So in the wake of the earthquake, 70% of the towers in Haiti were still functioning. They were overloaded to the point where phone calls weren't reliable, but you could send a text message. So the latency that text messaging allows meant that these were still getting through. And it still covered perhaps 80% of the Haitian population at this time. As with so many countries in the less developed parts of the world, text messaging is the dominant form of remote communication. It passes actual phone calls, emails, snail mail. However, the existing emergency systems, such as they existed in Haiti, completely failed at this time. The services themselves and their communication networks. But as the text messages were getting through, a team of us, all connected by Josh Nesbitt, a frontline SMS medic, quickly put together an SMS-based emergency response system. And from conception to launch, it was just 48 hours. So the communication barrier here, or the information barrier if you like, was that the emergency responders did not speak Kreyol. The primary responders to specific emergencies were the American military, and these messages would mean as much to them as they do to you. But needless to say, understanding what these messages mean and what locations they refer to was absolutely vital for the emergency response process. And so these are typical messages. People needing food and water, search and rescue, hospitals, supplies. So logistics was actually like a very large percentage of these messages. And the medical emergencies, which are not necessarily associated directly with the earthquake, but are just the kind of emergencies that an entire nation faces over any given period of time. So this collective effort was called Mission 4636. And it was a very simple process. So somebody in Haiti would send a message in Haitian Kreyol. It would come to a platform where the message was translated, categorized, and geolocated. And my role was coordinating this platform during the process. The message, now with a translation, a category, and the precise coordinates, were given to another team based out of Tufts University in Boston, where they refined the locations and worked with the responders to identify the actionable items and cluster like messages geographically on a map, which in turn the responders used to act upon. Who made these translations? Volunteers. We found volunteers a number of ways. The most successful way was that I simply went to every Facebook page with the name Kreyol or Haiti in it and asked if there were any Kreyol speakers could help. 1,000 people immediately put their hands up and said yes. So what this meant was that if you spoke Haitian Kreyol anywhere in the world, you could come online, log into our system, read messages one at a time, just in a simple form, type out the translation, click on a map where you know the location to be, and then these messages were streamed back to the responders. And these are the locations of the people who were doing these translations just in the first week alone. So in total, we had people come online for 49 different countries. And among the top 10 most prevalent countries was one on every continent. So it really was a global effort. And we're all collaborating online. So we had a simple online chat where everybody worked with each other to decide, where this location actually was, what this location is in relation to the landmarks around it, what is the particular translation in the slang for this region. These are just some of the amazing people who are the driving force behind this project, the volunteers around the world. And I'll give a special shout out here. So this is Josh Nesbitt who brought us all together. That's myself. And then these four on the end here are people from an organization called Haiti who do great work with crowdsourcing and mapping. And they were working out of Boston on the mapping effort directly with the responders. We're receiving about 1,000 messages per day. And they were over a variety of different topics. This is the general breakdown. So food distribution, missing persons, and the third most popular one was asking to forward a message. So there was a period of time when you could send a text message to this number 4636 in Haiti, which we had set up, but the people in Haiti weren't otherwise able to contact people outside of the country. So they'll send in messages to us saying, please contact my aunt in Miami and tell her that I am okay. And we're very happy to do this. The average turnaround time from somebody sending a message in Haitian Kreyol to it being translated, geolocated, and streamed back to the emergency responders was about 10 minutes. It was as little as 2. And more than anything else, it was the local knowledge of the people doing the translations which enabled us to leverage this collective intelligence of these crowdsourced volunteers into the emergency response process. So here we have Delilah and Apple collaborating online from San Francisco and Montreal, respectively, trying to translate messages for the emergency responders. So in the online chat room, Delilah is asking Apple for the location of Thomason. And Apple replies with the longitude and latitude. And note what he says here. He says, this area after Pétionville and Pèlerin 5 is not on Google Maps. We have no street names. So what that means is that even though this was not yet labeled on a map, this is an area where he grew up. He can look at this map here, he can look at the corresponding satellite photo, click on that point, and that generates the longitude and latitude. So it's his knowledge of this area which enables us to exactly pinpoint this location when this information is not yet captured in any digital system. The feedback from the responders in this case was the US Coast Guard responding to a child delivery. And I like this particular example because this is one of the few cases where the people were in a better condition than they otherwise would have been for the earthquake. In this case, a team of medics was dispatched by a helicopter, and this child got to enter the world with much greater health care than they otherwise would have. And I think this one example really demonstrates the ability that you can make a real-time difference from anywhere in the world. So as Apple says, I know this place like my pocket, which is a really cool saying that I'm trying to introduce into English. And as Delilah says, thank God you were here. And clearly here is now anywhere that you're able to connect. So we did this for 60,000 messages in total, not just the one example there, with the average turnaround time of 10 minutes. And this is a huge amount of data, which is hard to kind of get your head around. So that's not 60,000 messages, that's 60,000 messages, all within the first 3 months. So strung together, these messages would be the Lord of the Rings trilogy or the collective works of Jane Austen. It's an incredible amount of data to all be manually translated in real time. And this meant a lot to the people who were doing this. So this is something that I didn't actually consider when I was starting to engage people in this process, but it seems very obvious now. So if you've ever been away from home when a great disaster or even like a small tragedy has befallen the people you care about at home, you want nothing more than to be there and help. And being able to stay where you are and do nothing more than donate to aid agencies doesn't feel like enough. And this, we found, meant a lot to the people who were making the translations, helping in both their motivation and as a method for themselves to feel like they were engaged in the process of helping what were their own communities. And beyond simply translating geolocations, this quickly became part of a communication network that the Haitian community was using just in and of itself. So this is an example of the maps made by the Ushahidi people from the messages. So you can see clusters of different messages at locations or the different categories. And so the Haitian diaspora will come in online here. So if they were, by the end of the second week, they were in regular contact with all their relatives in Haiti via SMS, for the most part. And so if they had a relative that lived here, they might know the location of the nearest aid station, and they could go to this map, look at this, and give them directions. So in this particular case, this message came through saying that there is a center at a given address that helps wounded or burnt people. It was shared on the chat room by the people doing the translations. And as one person said that, I will pass it on. This is my cousin's hospital. So this was something that very quickly became a social tool for a community to help itself during this crisis. In terms of emergency response, we know we delivered the first food and water to about as many people as there were messages. So about 40 or 50,000 people, especially in remote areas which weren't near the centers which the NGOs had deployed. Which meant that for every message you translated, on average, you would be helping one person. In terms of emergency response, we're not sure either. We know it's hundreds of people who were saved either through search or rescue or later medevac situations. So this is from our contact in the Marine Corps. So when Hillary Clinton gave her speech about the freedom of the internet, which has sometimes been called the anti-China speech, she started it not with an example of freedom of the internet, but with actually the story of a text message, which came through our system in the very early days, with which we're able to route the search and rescue people. And the director of FEMA recognized this as well. So the crisis map of Haiti represents the most comprehensive and up-to-date map available to the humanitarian community. So a lot of the large organizations, even the military themselves, found that a lot of the intel that we had from these messages was greater than they were able to discover from having their own people on the ground. And I like this particular example. So this is when we were able to deliver food to a camp of 2,500 people. So an IDP settlement a little bit outside of Port-au-Prince, which had just been missed by the aid organizations until this point. And the reason I like this is that a text message of only 100 characters long, sent in Haitian Kreyol, was able to ensure that 2,500 people received the aid they so desperately needed. And the outcome of this project was also quite positive. So we're able to transfer this to a local service, working with the new number 177, and this has now become part of the ongoing emergency response system in Haiti. So we've been able to build this up from scratch, and now they take phone calls as well as text messages. One very fortuitous connection was with SummerSource. So SummerSource are an NGO that employ people working in microtasking centers around the world. So if you can come online and do like 5-cent tasks a minute at a time, you can earn something in the order of $2 to $3 an hour. So Amazon Mechanical Turk is a great example of a platform like this. That's not so much money here. That's a great salary if you're, for example, a Sudanese refugee in Kenya. They had signed an agreement to set up a microtasking center in Haiti just 20 minutes before the earthquake. In the wake of the earthquake, the people who were going to take these jobs said that we need work now more than ever. But this was going to be delayed because of the logistics of getting the computers into the country. So just as it was becoming less viable to continually engage volunteers to do the translation, we were able to instead transfer this to the SummerSource workers in Haiti, expedite the delivery of computers to the center in Mirabelais, and start transferring this to local ownership. So this was continuing the emergency response process and creating about 60 jobs in Haiti as part of that process. And this is Lila here, who is the head of SummerSource. And on the wall there is Jackie Poteau, who is running things within Haiti, and Lucas Bewald, who is the CEO of Crowdflower. They run a microtasking service, and they hosted the translation platform for us for free. So one of the outcomes of this is further deployments. So the success that we saw here as an information strategy has been deployed elsewhere. So this is in Pakistan. Taking reports down to the village level, we're able to map all of these. So this was reports both from NGOs directly and via SMS. And in fact, we're the only organization who were able to have this level of granularity. And we've seen great feedback from this as well. So this is some from Map Action recently, saying that we're the only source of village-level locations within these certain areas of Pakistan. And of course, our reward for success is the follow-up message. As soon as we were able to demonstrate this ability in one area, people were asking us to do this in other areas. This is still very new as well. We're trying to formalize even our existence as an organization undertaking these projects. But whether it's us or whether it's other organizations, I think this strategy of engaging people in the crisis-affected areas directly and then having a crowdsourcing platform to help manage this information is going to be a strategy that we will see in future crises. Especially because, as you saw in that picture, we will increasingly see crisis-affected regions where the cell phone towers are still active. Okay, so another strategy for processing large amounts of data. So machine learning. So using artificial intelligence and natural language processing to automatically label, translate, reroute, map information. So we might want to use this if we could not find or employ a crowd. If this was like a slow burn crisis rather than a sudden onset crisis, it's simply harder to find volunteers. And perhaps if privacy takes precedence over processing. So an example I'll show, we're working with medical records. Obviously, we can't employ either volunteers or people in a microtasking center to look at what will contain confidential patient information. And for scale as well. So we were able to process 60,000 messages thanks to thousands of very dedicated volunteers. But what if we needed to analyze millions of messages per day? This is something which is probably beyond the scope of what you could reasonably do with a crowdsourcing platform. And there's lots of reasons why you would want to apply natural language processing to medical SMS. So you could identify outbreaks early on. In the same way that Google Flu Trends looks at people searching for symptoms and then identify outbreaks. Imagine if you could look at the individual text messages sent between health workers for those same symptoms or the same mentions of the diseases or the medicines which are used to treat those diseases. So epidemiologists are very keen to look at this data. Another would be to route important data quickly. So I'm sure there were thousands of avenues with which people send in text messages in Haiti, which were not a dedicated emergency response system, which contained actionable information, but which did not make it to the responders. So it would be great that even though it may be only that 1 in a million message which does have this actionable information, we had these machine learning methods which could pull out that information for low cost. And to save time as well. So in the project that I'll be talking about in a minute, there are two fully trained doctors who support a patient population of about 250,000. And they currently use SMS to communicate with remote community health workers. And this is saving them a lot of time. Since they've used SMS rather than random motorcycle visits, they've been able to double the amount of TB patients, as one of the metrics that they've been able to see. And as well, the cost of sending the SMS is actually less than what they would have spent on the fuel of these motorcycles. So while the technology has been a great benefit to them, they've now become information managers. So these doctors spend on average 1 hour per day simply replying to these communications on SMS via frontline SMS. So this is a system where you can just plug any phone into a computer and manage your SMS in a database. And if you average that out, 1 hour per day for this patient population, it comes to about 5 seconds per patient per year. So it's not in my power to put more doctors in this clinic. But it is in my power to speed up this process as much as possible. So I can't put 10 times as many doctors in, but hopefully we can leverage machine learning technologies to automatically reroute and label these messages so that this process is 10 times faster. So these messages were in the Chichewa language. It has about 13 million speakers. It's a Bantu language. It's one of the national languages of Malawi. It's spoken predominantly in Malawi and a little bit over the border in Zambia and Mozambique. So this is partnered with Frontline SMS Medic, the clinic as you saw, and this has just recently been published. So unlike Haiti, where it was crisis response and we've done the research post hoc, This has been a more traditional approach where we've started doing pilot projects, we've demonstrated their success, and now we're integrating into the larger systems. So in the Chichewa language, variation is the norm. In just 600 text messages, these are spellings for the word patient in Chichewa, and then in English translations of all those messages. So as you can see in the English translations, there's just patient and the plural, patients. Whereas in Chichewa, while odwalla, nothing to do with the fruity drink, odwalla means patient or sickness. It's an unfortunate cognate. Is certainly the most dominant form. It's not even the majority. And in fact, most forms occur only once. And this is actually the norm. English is very unusual in that we have a very simple morphological system, so very few prefixes or suffixes, and very standardized spellings. But of course, spellings are less standardized across most of the world's languages, and within the medium as well. People abbreviate or text very quickly. And what this means is that keyword-based models are suboptimal. So 90% of research or industry into natural language processing use words as the atomic feature here. And so you can see this just, you search for words in Google and perhaps it knows the plural. But certainly for the majority of the world's languages, it doesn't go beyond those very simple suffixes. And perhaps also in something like the spam filters, which you define within your email. It's all keyword-based. Unfortunately, while 90% of the technologies work this way, 90% of the languages don't work this way. English has a very simple system, and the same approaches simply don't apply. So we need to model morphology. So here is a typical word in Chichewa. Fun means want. And here, this marks it as the first person. It's the imploring, so it's like a magnifier. The present tense, the second person, so it's I'm saying this to you. The just marks it as a verb, and the so is a suffix which means like also. So it means something like, I am also currently wanting you very much. So if I was expressing my very strong but non-exclusive love for you, this is something I might say in Chichewa. And there's also phonological and orthographic difference. So with odwalla, you might see the additional L or the R. And there's actually some debate as to whether the R is simply a write-in variation or whether it is dialectal variation in the pronunciation. Fortunately, the variation is non-random. So all the ways with which we see this write-in variation and this morphological variation is linguistically predictable. And what that means is that there are patterns in the data, and we can leverage forms of AI to find out what these patterns are. So this, in some slightly simplified steps, is the way with which we approach this problem. So here you've got two ways of someone expressing that they need medicine. One is I currently need medicine, another one is my want of medicine. And as you can see from the forms up at the top, there's zero match in keywords. And this means that your machine learning algorithm can't generalize over these two if it's using words alone. So the first thing we do is look at ways to normalize spellings based on common observed variation and non-letter pairings for which you could substitute each other. We segment this using unsupervised segmenter. So this means we simply look at the common subword patterns and see which occur together the most, and then assume that these are meaningful morphological units within the words. So you'll see in both these cases as correctly identified fun as as want, and ndi as the first person, so the I want. And then finally, we use supervised learning to identify the predictors. So given some historical data, where we've already broken up these segments, and we have the labels, so we've seen a category which says, like request for aid. It can learn that, oh, okay, nidi and fun, I've seen nidi and fun in these previous requests for aids. And the AI builds up its model of how to classify in this case. And what this takes us from is about 1 in 5 classification error from raw messages to 1 in 20 classification error post-processing. It actually improves with scale. And so Now that we've crossed this threshold to get us to about 95% accuracy, we can start plugging this into much larger systems to predict trends over large scales. And what was nice about our approach was that it was language independent. So we deliberately restrained our approach so that it didn't have any prior knowledge of the Chichewa language, meaning that we should be able to apply this as broadly as possible. So you can see this is the accuracy as it learns, and over all 600 messages, which is still a fairly small data set, you can see that with the Subword models, Chichewa is almost as accurate as with the English translations of the same messages. Not quite as accurate, but we're getting there. Whereas if we don't conduct this Subword modeling, there's actually no evidence that it's even converging on the same model. And this also demonstrates nicely, I think, the difference between English and the majority of the world's languages. So when we applied the Subword models to the English translations of these very same messages, there isn't a statistically significant increase in accuracy. And this really demonstrates that the methods that do work in English are not necessarily going to work for the majority of the world's languages. Okay, so outcomes, we're currently integrating with the people who run HealthMap. So this is a global GIS system which looks at prevailing trends around the world and different diseases for epidemiologists and local doctors alike. And so hopefully within the next 6 months we look to integrate machine learning into this process. So it's not just the manual entering of certain reports of epidemiology, but real-time monitoring using machine learning. Okay, so I'd just like to finish with, I guess, a plea for those of you in the room who are interested in doing research into language and cognition. So there are thousands of people, well actually there's about 1 million people right now who regularly log on to microtasking services around the world like Amazon Mechanical Turk to work for just a few dollars an hour. It will often be a competitive wage. And just recently I thought to ask them what languages they spoke. So I asked just 500 people on Amazon Mechanical Turk, what languages do you speak? And this was their result. There's more than 100 languages here. I mean, there's some fuzziness with interpretation because Hindi and Urdu are probably the same word. You might want to claim that Pig Latin and Klingon are not actually languages. But certainly there's a very rich linguistic diversity of people out there who speak these different languages. These languages are concentrated in Europe and Asia, so these are the origin of the languages, not the workers themselves. But it's also great to see some people online speaking like Yupik. So it's an Aleut Eskimo language in Alaska. There's a number of Austronesian languages which we only have like 1 or 2 research papers, in some cases not even devoted exclusively to these languages. And these people are sitting there right now at their computers. So I think we're going to see through microtasking and crowdsourcing a real explosion in the diversity of the language and cognition research that we were able to undertake, and in turn, hopefully leverage a lot of this into crisis response. So just to go back to my original graph, so here's where we are right now with access to 5,000 languages. And we can leverage these technologies not just for crisis response and health, but for education, for market access, so for information about how much the product that you're growing is worth here as opposed to the next valley. Microfinancing, mobile banking, and employment as well. Okay, thank you.
So do we have any questions for our speaker? Okay.
Thank you. That was a great presentation. The examples you gave all involved benevolent people collaborating. But in crowdsourcing, there's also an increasing amount of adversarial, exploitative, mercenary behavior. Don't projects like these have to deal with that too? And how do you do that, especially when lives are at stake?
That's a great question. So We just relied on the goodwill of people in Haiti. So we registered who they were. We didn't know who they were. We didn't really have a choice because of the sudden onset and the volume. With Pakistan, we're able to do things in a more structured way to help present against either malicious or simply accidental information by the crowd. So in the case of Pakistan, we gave messages to multiple people to map. And using, so again, we were using Crowdflower's platform. And they will compare the different people who work on a given task. And if it looks like there's disagreement between them, it goes to extra people. In addition, it keeps track of people across multiple tasks. So it builds up a confidence in the individual worker. And so this works well from both ends. So we get a confidence measure for every single item which is processed, and for the few which just are continually low confidence, we look at them manually. And it means as well that if you're out there somewhere in the world and you want to help, but you are worried about accidentally introducing bad information, you're protected from that as well. So if you make a mistake and click on the wrong map or identify the right village name in the wrong province, then that is going to have a red flag when someone else looks at that same message. It's not the silver bullet, but it goes a long way towards addressing that.
Thank you for your presentation and your efforts. You seem to have helped a lot of people with the technology. How does this work with pictograms like Chinese characters or kanji?
That's a good question. The segmentation model would equally apply to Chinese pictograms. So Chinese is typically written without word segmentation. And in fact, the algorithm I used here was originally developed for Chinese segmentation, so to pull out what the words are. So Chinese itself is very morphologically simple, much like English. So it's already got an advantage in that regard. But certainly in the segmentation task, it could be used. I haven't actually applied it, though. It's something I'd love to test sometime.
Okay.
Well, this is not a highly technical question, but I'm wondering how you got the word out in Haiti to people that this service was available and how they could reach it.
So through local radio. Working on the ground with the Thomson Reuters Foundation, like the charity wing of the news organization, and they drove around to local radio stations and they broadcast that people could send a text message to this number for free. And that was the initial word, and then following from that, as soon as we had volunteers helping out, it was their brother, their cousin, their uncle, who worked at various radio stations around Haiti, and they contacted them directly and kept that information going.
Thanks for a great presentation. I'm curious, you said average 10-minute response time. It's very impressive, but it's not very good if the emergency is a fire. And I'm wondering if there was some kind of triage mechanism.
Yeah, that's something we are also looking at with machine learning. So in Haiti, no. We're simply doing this as quickly as possible. To the extent that there was a triage mechanism, it was me reading these messages as they arrived, and if it seemed important. Yeah, there were cases where I would contact the responders directly. Not very many, because they had a lot of information. They didn't need me banging on their door. But yeah, certainly with machine learning, there's more or less zero latency. So within a second or two of a message arriving, we're going to be able to categorize that, perhaps translate it, and forward it immediately. And in fact, this is something we'll be trying in a couple of weeks. We're partnering with the UN on a drill for a mock earthquake in Colombia. And as well as the regular crowdsourced methods, in parallel, we're going to be running machine learning methods to see how successful they could be.
Hi, I'm not sure if you mentioned this before, but how did you get the word out to volunteers around the country that they could help?
Social media, yeah. So every Facebook page or group which had the word Haiti or Kreyol in it. In fact, the most successful place to do this was this page called, Together We Can Find 100,000 Translators of Haitian Kreyol. So it was a very Facebook name for a group. Fortunately, there were not hundreds of thousands, but there were certainly hundreds of people who were members of that group. And beyond that, it was very much a viral process. So some people within the Haitian community would know about this. They would contact their friends and families. And there were people who had set up basically situation rooms around the world where the Haitian community would come together, work together, maybe 5 at a time on computers in one room, translated messages, and then do this in shifts.
Okay, well, I think if we don't have any more questions, so thank you again for a great talk.